So let us start exploring flow to plan by taking a look at the activities that are already set out in time. Now what I have here is a Gantt chart and a breakdown into the various departments, trades or even co-makers or subcontractors that we have here at the yard, and an overview on the running projects. Now, currently I'm interested in seeing how the easy dredge vessel as a whole will be scheduled in time, and I see here the distinctive phases all the way down to trials. Now I know that the engineering, for instance, is broken down into both basic engineering as well as detailed engineering, and that perfectly relates to the approach that we take here, that we focus on all kinds of intermediary products to be completed in order for the ship to be completed. So detailed engineering will have a relation here on this level with particular items like blocks. So I now select an individual block, and I see here on a level 3 that there are detailed engineering activities for this particular block. Well, this allows me basically to have the need dates of production be in the lead also for the engineering planning, but that on the side I see here a breakdown of all these phases for this block, and when I add level 4 I can see which particular items need to be completed in order for that phase to be concluded. So I see a section drawing assigned to the detailed design department, and even production engineering, also detailed design department. So there are other examples here as well, like cutting and forming, and what we see is that the, let's say, summary of all these level 4 tasks, so these are level 4 tasks as you see here in the recognition, all these level 4 tasks summarize to the level 3, and that summarizes to level 2, and therewith project management has a complete overview based on granularity. While this level of granularity with these very small items being assigned to shops, they allow us to also really enhance and optimize the processes on the yard as a whole, because on the backside we can also make all kinds of resource overview and dashboards that really allow us to make proper decisions on what is more optimized, and this granularity therefore helps us greatly. While there are more products that we need to complete for completing this vessel than just the blocks, we also have rooms, areas and systems, for instance. So if I now take a look at a deck, I have here the bridge deck, and I'm interested in the rooms that need to be completed on the bridge deck. So I select level 3, and I see here there needs to be a wheelhouse completed with technical and functional outfitting to take place. And when I add level 4, I can see which distinctive tasks need to be completed in order for these phases to be completed. So I see install of ducts and position equipment, frames and doors, all assigned in this example to the carpentry department. But there's more, because I can also see, for instance, what is the total workload for the engineering for this particular vessel, and therewith I select level 3 activities, and I see all kinds of drawings for the mid-body, 2 mid-body blocks, but also some structural engineering work. If I want to take a multi-project perspective, I just add another project, press apply, and I see the whole workload for the engineering department. The engineering department is broken down also into various disciplines or trades, so one of them being the detailed design. So when I now select detailed design, I get an overview on all the detailed planned activities for these 2 particular vessels. So multi-project approach here as well, and the same goes for subcontractor. I can also take a look at what is all planned from this vessel for a subcontractor. So diagrams, for instance, will be planned here as well. So it's a combination of an integrated plan that works with a product breakdown and a work breakdown, and far more granularity than you might be accustomed to. Setting up such projects is obviously very interesting to take a look at, because it makes a lot of difference how much effort you should put in making such plans, and that's what I will show you in the next topic, where our focus will be on how this plan is actually set up and how we can mature the planning over time when the engineering 3D model is maturing, because more information becomes available. So let us take a look at how these projects are actually set up and planned. Initially, what I find here when I select the Projects tab is an overview of running projects sorted by their type or status. And when I select an individual project, I can see some generic information on calculation data, so the rates for the various trades involved, the baselines. I can upload files here, and everything here that is related to the project as a whole. Now, underneath the project is the product, which is in this case is the easy dredge vessel that we are building, and we see here the master level planning as we saw before in the Gantt chart. Underneath this level of initial planning is a breakdown into the various products that we need to complete in order for this ship to be completed. And we'll find here the mid-body, so there are two blocks here, there are some spaces, systems, and obviously drawings. Now if we take a look at, for instance, the mid-body block, then we see a breakdown here of that particular block into the various phases as we saw in the Gantt chart before as well. We know from the recognition of our toolset that a mid-body block always has a certain sequence and a certain setup of activities. So we know that a mid-body block, for instance, always has panel production. Now, panel production is always assigned within this shipyard to the assembly hall where the ironwork and the welding takes place. But we also know that a panel production always is preceded by cutting and forming and is always succeeded by the block assembly. What you see here as well is all kinds of individual panels, and they are not known to us at the start of the project. Obviously, they will arise or mature through the engineering model over time, but when we recognize them within the model, we can synchronize them and have them become available here as well, and they will follow a certain hierarchy where I can elaborate a bit more on separately, but these panels are recognized here as well. So this individual panel, we know the type of panel involved here, and we know therefore that it always requires assembling and mounting. And because we know the properties of this panel being the weight, we have a production norm that allows us to calculate that this will take 30 hours for mounting and 60 hours for assembling. So therewith we have all kinds of products that together have a work breakdown and that we combine together to create this vessel. Now we also know that this vessel will carry a ballast system on board, but we don't know at this point how that ballast system will be positioned within the ship. We don't know exactly to which rooms it will belong, if it will relate to other systems and which ones. We just don't know at this point, and we also don't know to which foundations it needs to be mounted. But we do know that from a production planning perspective, it's a similar ballast system as we have had on a different project as well. So what I will do here is I will select the Kpis hull project, because that also has a ballast system on board. I select here that particular ballast system, I copy it, and then it now positions itself within our current planning. It will create all kinds of activities, and the detailed design, for instance, will relate to the generic overview detailed planning activities, and the same goes for fabrication and testing. If I now run it, you will see that it has now positioned itself in the planning. So once we know more about it, as the engineering model matures, we can add all kinds of structures to it. And let's say there's a relation to other systems here, like for instance, a fuel system. Well, it's not available here as well already now, but the same goes for blocks. And this way we can very rapidly create a planning with all kinds of products from things we know from the past, which are in our library, either in our template library or in our history library. And this way we can plan projects very rapidly. And we can also use the engineering 3D model to do a lot of this work for us, because if that model already carries that knowledge, we can just use those properties to do planning very rapidly. So what I will show you in the subsequent topic is how we can actually include the engineering model in this approach. So let us take a look at how the engineering 3D model can enhance our planning approach. Take a look at the division of the various projects and select the Watchler demo project in which we are interested, because we know that it's already synced with the model on the background. There's a division here into 3 distinctive blocks. I have a preview here of the block, and I also see here a breakdown in the various activities and relations for this particular block. Last activity on this train is the outfitting that takes place, and the steel work for this outfitting, the secondary steel, is already recognized here because they are pulled from the model. I also see here a section, the train of activities for that section, and the preview for that section, and the same goes for the individual panels. So I have here a panel with a train of activities, and here's a preview already. So we can now see all these distinctive items coming from the model itself. So I have here the engineering 3D model, block 103, which I can examine, leaving behind all other objects. I see here that it's already outfitted somewhat. A lot of systems have been included, but I'm now interested in seeing just how the steelwork is broken down. So I now see the steelwork, and I want to know more about unit 1, which I can then examine and see how these distinctive items are all part of that section or unit. Now, that whole hierarchy has been synchronized with flow to plan, so I see all that here for these particular individual items. And what we have now in flow to plan is a recognition of that whole product breakdown structure for that vessel, both on the end of the structural work as well as for the outfitting and the division into rooms, etc. But all individual parts are now recognized within their hierarchy, and for each of these parts we know what type of part it is or intermediary product it is, and we therefore can generate a train of activities for that particular item to be completed. Now, together with the train of activities, we also can assess the size of the activity involved by taking a look at the properties. So in this example, we have seen that there's a weld method here, MIG-MAC, which is associated with this panel, but also the total welding length. And based on these parameters, we can determine the size of all these activities. So we have determined the budget for this activity, and we have recognized that since it's an assembling activity, it is associated with the metal shop, and it includes all these 3 distinctive trades. So this is basically the setup for the steelwork, but obviously we have more. We also have rooms available in this ship, and within the rooms we have systems. So this ballast system that runs through multiple rooms obviously has a range of spools that need to be fabricated and mounted. Here is a division of 4 different spools that belong to the ballast system and need to be ultimately be completed in or mounted in room L. So that division or structure is provided here, and what we see is that every individual spool also has a train of activities to be completed, but these items can be fabricated together in one bunch, in one work package, and therefore we also see that this individual spool not only belongs to this system in this room, but it also belongs to the piping block pre-outfitting work, for which it will be separately fabricated together with all the other spools that belong to the same block but will be in different rooms. So it's a very granular approach where we can quite granular recognize how all these items come together. And that is basically the added value of using the engineering model's data as it matures over time when more engineering details become available, and use that for planning purposes. Now, the benefit of having everything relating to planning and control be available in one tool is that everybody can look at the same plan from its own perspective and have actual information. Now, on the right, we see how this particular carpentry department is evolving when it comes to the resource occupation and how he's performing for this shop in terms of having the items be ready on time. And then on the left, I see a breakdown into the 2 distinctive projects that are now running in this carpentry department, and I see a breakdown into the various rooms in which activities take place. If I now select one individual room, then I see all the activities that are assigned to me throughout this room, and I can see how all the dependencies and relations within that particular room are now grouped together. I see the preceding and the succeeding tasks as well. Now, obviously, when we also have quality control items be addressed throughout this particular room, then the quality control department will also have activities be assigned to them, but their layout and look ahead is different because they have a limited scope. They only have quality control items, which you see here left as well. So in this example, it shows you that all distinctive departments have a different breakdown that also are dependent on their logic and which obviously deviate when it comes to resources and performance. But this perfectly shows you how everything works from one and the same planning. I can provide the supervisor here with an overview on a multi-project perspective on what is all assigned to his shop, and he can create an overview of where the dependencies come from, if things will be able to start on time, and also to assess where to put on his crew, which activities might need more people assigned to it to complete everything on time. Now I have here a progress screen that allows me to recognize as a supervisor or a co-maker, if you would provide them with this similar screen, how the performance of this department is running for these activities. So I can submit a weekly overview here on the level of progress and what the actual planned finish date is, and therewith the centralized project plan is updated, deviations are recognized, and mitigating actions can take place. We also have here obviously the logic of an engineering department, where you see that the distinctive engineering drawings need to be completed, and the same goes for the assembly hall. Now for the assembly hall, it's interesting that they are grouped into blocks and units, that they can too find here all the activities that are associated with certain blocks or units, as you see here. If they want to know more about how a particular block is set together, or where the dimensions are, or any other particular information, then you see here that there are already some files available on the unit here, but if they want to know more, they can just access the eShare just instantly from here, find the eShare 3D model and recognize the part status within to see if things have been nested or not, but it can also make measurements here or find additional documents. So what you do see here is that the engineering 3D model also can be made available on the shop floor through a recognition of planned activities. While every yard is different and also every department has a different emphasis, we do have the ability within Flow2Plan to apply a very granular approach to managing teams and making sure that the hours spent on activities are correct. What we have for that approach, for instance, is here the plan board, where individual tasks are assigned to individual persons, making sure that the trade required, for instance welding certificates or whatever, match the requirements of the individual person. Now here you see a QC team which consists of these 4 people, and now I will assign PIM to the QC of paint as well as installation, and what I now see here is who is assigned to what, as well as to what is he assigned. Now what now can be made available is when PIM is accessing Flow2Plan from a screen hanging on the wall, then he can instantly submit his time on these cards. So he sees now these 2 activities. He's worked 4 hours on QC paint and 4 hours on QC installation, and therewith he has booked his time for the day. So that's basically one of the approaches that we take to both control hours and make sure the hours are accurate, as well as making sure that the trades and the activities are properly matching. We know that a lot of yards really struggle to keep up with their time tracking as well as progress reporting scheme, and that supervisors on average take around an hour a day to do all this administrative work. We've put a lot of emphasis in making sure that submitting time, retrieving time, validating the input is limited to less than 10 minutes a day. So what you see here is how the supervisor validates the input for all the participants of his team with, in this example, a weekly timesheet. There's a sequence available here where you have a validation of input by either the foreman or the HR department, and that either the hours come directly from the shop floor or from the supervisors. And we see oftentimes a division where steelwork supervisors are the lead, but other departments such as carpentry, the hours are booked by the workers themselves, as there are more active tasks at any given moment. And yeah, that's just some division that we see. So now throughout the week, I want to recognize as a project manager where we are with our project, and therefore I see the Gantt chart here with all the distinctive activities, and I see here in gray what might have been changed. Well, gray means nothing has changed, but here in orange I see that there has been a change made, and it allows me now to approve or disapprove of that change. That was an example with just timelines, but this is an example here with also a change in progress and budget. And if I want to know more about either this particular level and how that impacts our plan, I can take a look at a project planning level and what the impact would be of changing timelines. But I can also take a look here at the project KPIs and dive into the specifics of this particular project, where I see a schedule and a cost performance index. I see the hours to go ahead in time. I can see the deviation of particular departments. So how are they performing? But I can also use S-curves to see all these intermediary products that we are creating. If it's a block, a unit, a room, or whatever particular intermediary product we have within the yard, I can look it up here and make a comparison and break it down even on a trade level. Now, there's also the capacity dashboard that allows me to recognize how the forecasting of all these particular items and the hours to go will impact the whole of the shipyard, including the trades involved. And if I want to know more about how everything comes together, I can also take a look at the 3D model, where we have the recognition of status. So each individual part with the train of activity can be sent back here to account for, have these parts been fabricated, have they been mounted, yes or no. So in this example you see the panel status, the level of completion for each panel, but the same would apply for section planning, and where are we with the progress of the section or the block as a whole. This is all integrated and therefore to be used for an integrated framework controlling your yard and project.